Today I'm doing 8.1 graphing and writing linear functions, and we're also going over 3.5 because they're almost the same. The only difference is 8.1 you have something where you have to graph in this form. In 3.5 all you have to do is graph by looking at the y-intercepts. Also, the difference with 8.1, they want everything in function notation, which is denoted like this. These are function notations. That's different. They don't want you to use a y equals, they want you to use the f of x, which is the same thing, except maybe when you get into the rules of it, that's where it changes a little bit. So let me do this one. So they're giving you function f and function g x. So these are the x's on this side, and they want you to substitute those x's into those x's in the functions. So all you have to do, for example, I'm not going to write the a to save space, so let me write it like this. So that's the first function. Second g of x would be, I'm putting parentheses for x because that's where we're substituting. Okay, like that. So for the x, which is this parentheses, we're going to substitute 0, which is the x's. Remember, the x's are independent. You choose them randomly or arbitrarily so that you get the form of the line on the positive and negative sides of each quadrant. That's why they choose these numbers, and they choose some negatives to have the scope of the whole thing. 1, -1, and -2. So you substitute those x's into for that x. Over here, the same thing. You use the same x. 0, 1, -1, and -2. Okay, once you have that, let's solve for the first one. So obviously 3 times would be 0. 3 times 0, 0. This one would be -3. This one would be both negative, so +3, and that one would be +6. In this case, so that becomes 0, so you get -6. So that's -3 times 1, -3 minus 6 gives you -9. So these are the values that I'm getting when I substitute this x into that x. These are the y's. These are the y's. But we're doing function notation. I'm gonna just put y here so that you guys know what I'm doing. Y equals that when you substitute x. F of x, that would be like y. I'm just gonna put it over here so that they're the same. Y equals -3x. F of x equals -3x. Okay, here let's continue. That would be +3 minus 6. That will give you -3, and that one would be +6 minus 6. That will give you 0. 3 times 2 6 minus the 6 gives you 0. So these are the y's again of this function, because there's two different functions. After that, let's write the order pair. So this is the order pair. I'm gonna put it here in reds. So remember, order pair, the x goes first. So where should I write it? Maybe here, x and y. X and y. So the x's are 0, 1, -1, and -2. And the y's, right? The y's would be the 0, the -3, the +3, and the +6 for this one. Now let's write it for this one. These are all the order pair because we need them to graph. That's why I'm doing this. So again, the same x's, 0, 1, -1, and -2, and then we got -6 here. We got -9 right here. We got -3, and we got 0. So these are the order pairs. You're gonna use those numbers to graph each function. So now let's graph it. Let's start with f of x, 0, 0. So that's the origin right here. That's how you find 0, 0. Positive 1, so you move 1 on the x, and then y comes second, negative 3, so about right there. And then negative 1, so now this way for the x, and then positive 3, and then negative 2, 2 this way, and then positive 6. So more or less this line will look like this. And this line is f of x negative 3x. So that's this function. Now let's graph this one. So you start from 0 and you go down to 6. And then positive 1 here, and then you go down to negative 9 right here. And then negative 1 not this way, and then negative 3, so about right there. And then negative 2, 0, so it stays there. So this line, it should have been, they should have looked parallel, but this is not accurate, but that's how the line looks. So what happens between these two lines? Again, they're parallel, so I'm not writing here, even though this one is kind of crooked. The parallel lines, they have different slopes. They mean different y-intercepts, but the same slope. Okay, what happened? What happened in words? The line, so I'm gonna put line f of x, which is this one. Let me write that this is g of x over here, negative 3x minus 6. If you notice there, this part is the same as this one, this part. The only difference is this function has a minus 6. So they want you guys to understand what happened. What happened, this is f of x, which is this. And it went down 1, 2, 3, 4, 5, 6 units. So this line went down 6 units. So line f of x was shifted 6 units down to form function, or to get, maybe it would be function g of x, which is down. So that's all that happened. Okay, and that's the answer for that. You need to graph these and graph it the way I did. Now let's go to the other question, and that would be 3. Hopefully I have time to finish because I have a meeting right now. So this is question 3, and it's asking you to get that line. So find an equation of the line with slope negative 3 and y-intercept. So they're giving you the slope and the y-intercept. Write the equation in function notation. So this is just the f of x thing. So they gave us the slope and they gave us this. So before we move on, let me show you, for everything else that follows, we're going to be using this type of equations or forms of equations. So forms of linear equation. That's the first one, and it's called standard form. Ax plus by equals c. The x and the y, they're on the left side of the equation, and you have a constant. A, b, and c are numbers. A and b are not both 0, so these two cannot be both 0. Okay, this is the other form. It's called the slope-intercept form, or y-intercept form, they call it also. The m is the slope, and the b is the y-intercept, and that's how you denote it. For y-intercept, the first value, which is x, and the second is y. For y-intercept, the x is over 0, and then the second value, it's a y, and that would be the y-intercept, and that's what b is, the y-intercept. That's why I put b equals y-intercept, which is that number, second number. And this is another form, point-slope form, and this is used to find that equation. So you go from here to here, or you go from here to here to here. So when do you use that? It tells you right here, point slope. They give you a point. Whenever you get a point and the slope, so the m is the slope, and they give you a point on the line, so point on the line, you know you're gonna use that one. That's why it's called point slope. This should tell you when to use it. Point and slope, you use that one. And that's, you use that one to get these or that. Okay, horizontal lines, that's how they look. It's a horizontal line, and that's that's the equation, y equals c. So these are equations I show you here. This is another equation, and this is for horizontal lines. This C is a y-intercept in horizontal lines. So remember what I told you, x, and in this case, y, in this case they call it c. That would be that, whatever number you have here will go here. And that's how you denote equations like that. In function notation, well, you will use f of x for this. Or actually not for that one because it's horizontal. So for this one, you got a vertical line. So this is the vertical line going up and down. And that's how you denote it. Very similar to this, except that you have an x now. So instead of the y value, you have the x, and that's how you graph it. So what does that C again represent? Now it's no longer the y-intercept because it's a vertical line now. Look where it's touching. It's touching the x-intercept. This is the x-axis, the x-intercept. And that's how you denote it now. The x comes first and then the y. Now the y is 0. And the c is over here, and that's the number that you would put here for this equation. It's the opposite of this. 0c, and this is z0. C is the y-intercept for that one. C is the x-intercept for this one, because that one touches the y-axis here, and that one it touches the x-axis. Okay, the last two, remember, you're gonna get lines. When they're parallel lines, they have the same slope, so the slopes will be equal, but they will have different y-intercepts. Perpendicular lines, so again, these are, I should have wrote the graph, so these are parallel lines like this. They have the same slope and different y-intercepts. This one's so this one would be something like this. So they're perpendicular. So these lines have opposite reciprocal slopes, and that's examples of opposite reciprocals. So what does the word opposite means? It means you change the sign. So you start with a positive, the opposite would be a negative. Here we start with a negative, the opposite would be a positive. What the reciprocal means, you flip the numbers. This 3/4, it would be 4/3 would be the reciprocal. 5, there's a 1 here, even though they don't put it, so the reciprocal would be 1/5. Again, you change the signs because they're opposites. So these are the forms that we're using for today. So for this one, we're using, we're gonna use, I think it's better if we use the y-intercept form, which is this one, y equals mx plus b. So find the equation, they gave us the slope and the y-intercept. So remember, this is the slope, and that's the y-intercept. So remember, this is x, y, and x is for y-intercept, x is over 0 here, and then the -5. So you know this is 0, b for this. So b is -5, right? Which is that number right here. For slope, it's just given to you is -3. So slope equals -3. So now you have to do substitute here. So y equals x plus, so -3, the slope, and then -5. Now they want it in function notation. All you have to do is write it as f of x equals -3 x plus -5. And that would be the answer for this one. You could have wrote it like this if you wanted. So you would have had -3 and then -5, and then the x just like that. They're the same thing. I just took out the positive and just included the negative here. That's the only difference. So that's the function notation. That's the equation. That's the function notation. That's the thing that changes this. Okay, let's move on. So this is how you find it. So for the next one, it's asking you, I know you can't really see here, it's asking you to find an equation of the horizontal line containing the points, these points, and write the equation using function like the other one. Okay, so horizontal lines, if you remember, that's where you go back here and look. So how does horizontal lines equations look? Horizontal lines, so they look like this. So write it. So horizontal lines have this form. What does this represent? So the C would be the y-intercept. So on here, the y-intercept would look 0, z. So this is a y-intercept, would look 0, 0. Now they're telling us that a point on this line, that's a point on that line. So let's find that point on that line so that it makes sense. So 2, x2, right? And 3, so here. So we know that point, it's on that horizontal line. How does a horizontal line look? Like this. Okay, so that means it's in touching the y-axis at 3. So that means that's the y-intercept. It would be 0, 3. So the y-intercept would be, I'm going to write it in red, would be 0, 3. So that means that C has to equal 3. So all you have to do is substitute now into the equation for horizontal lines. That's the equation for horizontal lines. So you would have y equals, let me put it in red, 3. That's the equation of that line. Now they want it in function notation, so all you have to do is, let me see, yeah, all you have to do is f of x equals 3. So that would be the answer. That's the equation, that's a function notation of that line. So remember, this is y equals 3 or f of x equals 3. That's the function for that line. Okay, number 6. So number 6 is asking you to find the equation of the line containing the point, that's a point, and parallel to the line. So remember, so they want you to find an equation, and they're saying that line is parallel to this line. So this is a different equation. You still need to find the other one that's parallel to that. So remember, when lines are parallel, they have the same slope. Different y-intercepts, but we know they have the same slope. Okay, so I'm gonna put here our line, and then this is a line given. So this is a line they gave you. And they're parallel, so that means they have the same slope. So in order to find the slope, we would need to find the slope of that by finding the slope of this. And since you know the slopes of our line and this line are equal, you would be finding our slope of our line. Okay, so let's work with what's given to us. So that's the other line. So how can we find the slope of this line? There's different ways, but we're gonna have to convert. So convert to the y-intercept, to this one, the slope-intercept form. This one, the slope-intercept form. So we're gonna make that line look like this, because by looking like this, we know that the end would be the slope. to slope intercept form. Form, which is equals mx plus b. So that's what we're looking for. So now let's use that line. So we're gonna carry the x because the x needs to be on the right side. That becomes 0, so you have 3y equals negative 2x minus 6, and then you divide by 3 all terms, so that becomes 1. So y equals negative 2/3 x minus 6 divided by 3 is 2. So that's the other line. So the slope of this line would be negative 2/3. So that means if these lines are parallel, that means our slope, our line, has the same slope. So you're going to write it here. So that's our slope because it has to be the same as this line. Now, after this, we have the slope and we have a point. So what did I tell you? When you have a point and a slope, you're going to use a point slope form. What's a point slope form? Y equals y minus 1 equals m x minus x1. That's a point slope form, which is this one over here. Point slope form is that. They gave us a slope and we get a point. Just be careful with this formula. You need to keep that negative always, so I'm alright. So now we need to substitute for the point. That's the point, and then for the slope, that's the slope. So this is the x and that's the y. So y minus, and I'm going to put parentheses, equals, the slope is 2/3 x minus parentheses. So what goes here? The y, which is 4, and here the y, which is 4. So after that, we know on this side it's going to be y minus 4, and then 2/3 x minus 4. And then you distribute. Okay, so we get y minus 4 negative 2/3 x, and then 2 times 4 is 8. Both negatives, so you're going to have positive 8/3. Alright, 8/3. And then let's carry that 4 over to that side. So y equals negative 2/3 x plus 8/3 plus 4. Okay. So now we have to add this these two. So it's 8/3 plus 4/1. So when you add this, you do the butterfly. 8, 12/3. 8 plus 12 is 20/3. So this would be y equals negative 2/3 x plus 20/3. Alright. And I didn't notice, but they want us to use the standard form. So the standard form, now they want us to go back to that form. And I should have done it before, so now we need to bring the x and the y to that side. So all you have to do after that, so convert to standard form, which is ax plus by equals c. So let me put it here. This is where it continues. So you have y equals 2/3 x plus 20/3, and then we need to convert to this form. Okay, so let's carry it over. So plus 2/3 x plus 2/3 x. So that's 0. So you end up with 20/3 on this side. and then you have 2/3 x plus y on that side because we want x and y on the one side. We have that 3 and we have that 3, so we can multiply by 3 because we don't want fractions here. So what happens here? You cancel, so you get 20. What happens here? 3 times 2 is 6 divided by 3 would be 2x. So you distribute plus 3y, right? There's a 1, 3 times 1, 3y. And that would be the answer for 6. Okay, the last example. That one was long. So the last example 7, they want you guys to write the function that describes the line containing the points and perpendicular to that. So again, our line and the line given. So what do we know of our line? We know it has a point 4, 4. Okay. And in this case, they don't want us to do the standard form, so we can leave it as the slope intercept, which is this. Slope intercept y equals mx plus b. Okay, so the line given is this. 2x plus 3y equals -6. So they want us to find the slope of this, and that way we know that the slope of this would be the opposite reciprocal. So our slope would be the opposite reciprocal. So again, let's solve for y. So 2x, that's 0. So 3y equals -2x minus 6. Divide by 3, divide by 3. So y equals -2/3 x minus 2. So the slope of this line is -2/3. So what's the opposite reciprocal of this? So let's find the opposite reciprocal. So we get 2/3. The opposite reciprocal would be change the sign, so you would get a positive, and then flip the fraction, so 3/2. Sorry, 3/2. So our slope is 3/2 positive. 3/2. So we got the point and we got the slope. So you get a point and the slope. You're gonna use the point slope form, which is y minus y1 equals x minus the slope x minus x1. The y1 and the x1 are the points, and that's the slope. So write it down, 1 and then parentheses. The slope is 3/2. Yes. Positive 3/2. Right here. Yes. And then x minus that. So what are the points? The point would be 4, 4. So x and y. So the y is 4 and the x is 4. So y minus 4 equals 3/2 x minus 4. And then distribute this. So y minus 4, 3/2 x. 3 times 4, 12/2. So y minus 4 equals 3/2 x minus 6. And then you add, sorry. So this is what I have so far. So 3 times 4, 12/2. And 3/2 times x would that be? And then you add the 4. So y equals 3/2 x. And that would be -2. Let me see, and that would be the answer. I think they wanted in function. So you would have f of x equals 3/2 x minus 2. And that would be the answer for number 7. Thank you guys, that's all.